go, 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 go. No. Okay, go ahead. Okay, ready? Yes. Go. Why is this skipping the ice?
Oh my gosh.
The molar rocket is what starts off our whole
Macro. When an ice cube melts, it is taking in heat to change from a solid state to a liquid. In this case, we see a physical change occurring. This reaction is endothermic because the ice cube is getting warmer by absorbing the heat and melting. In this reaction, the ice cube is moved into a beaker that is placed on top of a hot plate. Acts as the catalyst in this reaction by making the ice cube melt faster. Nano. When the ice cube is in a solid state, the molecules are in a structured pattern. When the ice cube is melting, the heat or energy is added, making the molecules move around quickly. This happening makes the structure of the ice cube fall apart. Symbolic. H2O.
At this stage of our Rube Goldberg machine, we use a soda and Diet Coke eruption, as it was introduced in the Mythbuster. At the macro level, when menthol falls into Diet Coke, it dissolves in it and reacts vigorously with the Diet Coke. Then the reaction produces a lot of gases so that the balloon inflates and becomes larger. And then the inflated balloon hits the seesaw and elevates it to cause the next action. At the nano level, the menthol surface has a lot of pits, which are little craters, and those are called the nucleation sites. So when the menthol is dropped into the Diet Coke, the CO2 molecules already in the Diet Coke stick to those little pits and form bubbles, and those bubbles release gas. So the CO2 aqueous CO2 aqueous molecules becomes gases through this reaction. And at the symbolic level, the CO2 aqueous becomes CO2 gas. So it is just a physical change, since no chemical property has been changed, and it is a change of the state of matter. So menthol acts as a thing that provides the nucleation sites, so that the CO2 molecules in the Diet Coke use that nucleation sites to form a lot of bubbles and transfer from CO2 aqueous to CO2 gas.
Okay. This is the battery cell part of our Rube Goldberg project. It's a chemical equation. The macro part is that the zinc metal and zinc nitrate solution, along with copper metal and copper nitrate solution, that's connected by a salt bridge containing potassium nitrate. They conduct electricity and conduct a certain voltage which lights an LED. As soon as we corrode the aluminum piece that's shorting the circuit. So the nano part is that the zinc is the anode, which is the negative portion of the battery. It loses electrons to the copper. And the copper is the cathode, which is the positive part of the battery. And it gains mass because it gains more electrons. The salt bridge provides a place for the nitrate ions from the zinc and the copper to travel as new bonds are formed, because the nitrate is a spectator ion in this reaction. And the aluminum shorts the circuit. And so the symbolic piece is that zinc metal, which is neutral charge, plus copper nitrate, which has a 2+ charge, and reacts to, it's in a single replacement reaction to form zinc nitrate and copper, elemental copper, which is neutral, and zinc in this case becomes 2 positive. And it's also an oxidation reduction reaction because zinc loses electrons and copper gains electrons. And reaction is that zinc loses 2 electrons and copper gains 2 electrons. The potential voltage is 1.1 volts for this whole reaction, which is why we needed more than one battery, because the minimum amount of voltage needed to light the LDU as we tested in the lab was 1.8 volts. And zinc displaces copper because zinc is more reactive than copper as a metal.
Macro. CuCl2 plus Al is a chemical reaction. Chlorine acts like if it is an acid and is munching away at the aluminum, leaving behind the copper portion of the copper chloride. So in the end, you have a solution of water and aluminum chloride gas, with chloride being the precipitate. This is pure copper. The smell and gas released was the aluminum chloride. Aluminum is a more reactive metal, so it is replacing copper in the equation. Nano. Aluminum, copper, and chloride atoms are separated after the water is added. I think the water is the only catalyst in this reaction because it speeds up the process. And then the aluminum and the chloride join together and the copper is separated, making this a single replacement reaction. Symbolic. CuCl2 plus Al, with the product being Cu solid plus AlCl3.